The next chapter is on solutions and their properties. The one thing that you should think about when you're studying solutions is that a solution is nothing but a homogeneous mixture of a solute and a solvent. So at all times we will be thinking about mixtures which contain at least two components, one which is the bulk quantity, which is called as the solvent, and the other will be called as the solute, and this will be the one that will be lesser in amount. Recall from General Chemistry 1 that mixtures in general could be of two kinds. You could have a heterogeneous mixture or a homogeneous mixture depending on how well the solute mixes with the solvent. If you see that the components are visually non-uniform, then you will say that there are regions of different composition, and you would say such a mixture is heterogeneous mixture. Good examples will be oil and water, sand and water. On the other hand, a homogeneous mixture would be one in which the mixing is pretty uniform. So if you consider salt and water, for example, or the formation of an alloy, those are cases of a homogeneous mixture, and will be classified according to whether you have the size of particles as really small, as in the case of a solution, or slightly big, as in the case of a colloid. So in general, if somebody had to differentiate between a solution and a colloid, one could say that a solution is first off a homogeneous mixture. So again, the particles of the solute, the quantity or the component which is present in smaller quantities, um, is going to be pretty uniform with the bulk component. The size of the particles in this case is going to be pretty low in the sub-nanomolar range. These could be colored or they could be transparent, but when you just let it stand, it doesn't separate out. What I mean by that is if you take, let's say, salt solution and you let it sit for the longest period of time possible, it's not that it's going to segregate into a salt region and a water region. That remains uniform throughout. Likewise, if you compare that to, let's say, milk or fog, they're about the same, just that the particle size is a little bit bigger as compared to the solution. It's a sub-micro level. On the other hand, if you now compare that to a heterogeneous mixture, for instance, like a lotion, and you allow it to sit for a long time, things will settle down. You will see the creamier part in one end, and the watery part in the other. Or if you consider sand and water, you give it a stir and it looks like it's all together. But when you give it time to settle down, sand will separate out from water, which you then can decant and hence separate out from each other. Now, when you're thinking of solutions, like I said, there are two components of solutions. One is called as a solute, the other is called as a solvent, and the bulk quantity, the material that is present in bulk quantity, will be called as a solvent, and what is present in smaller amounts will be called as solute. The neat thing about this is that when you're saying a solution of salt, a solution of sulfuric acid, a solution of ink, whatever it is, you really are focusing on what the solute is. So, in a sense, one can say that even though the solvent is the quantity which is in bulk, this is what is used to dissolve. We still use the definition of the solute to decipher what the solution is built up of. And if it is an aqueous solution, that means it contains water in bulk, then you just say aqueous solution of salt, and that would automatically mean the word aqueous automatically would define that the bulk quantity, the solvent there, is going to be water, and that has been used to dissolve the salt. a lot of times, and we are going to discuss that later in several videos, a lot of times we have to specify the concentration. We can't just say in a quantitative sense concentrated or dilute. We have to specify how much, in which case we will use terms like 0.5 molar sodium chloride, and that automatically tells you that the concentration is zero point 0.5 molar. That means zero point 0.5 moles of sodium chloride in 1 liter of solution. And like I said, we are going to discuss this at a later time in good detail, but realize for now that a solvent is what is used in the bulk quantity, that is the liquid that you use to dissolve. On the other hand, the solute is the dissolved substance. But it's not necessary that you always will have a solution where your solute is solid and your solvent is liquid. You can have a liquid and liquid, you can have a gas and liquid, you can have a solid and solid, but for the most part in this chapter, we are going to talk about solutions that require a solid uh, a solid substance which will be dissolved in a liquid solvent. Now, the first question is, what is a saturated solution? A saturated solution will be that in which we have added enough solute that the liquid cannot hold any more solid. So we have basically we have acquired the maximum amount of the solute that can be fitted within a given solvent. Realize when you're putting in a solute in the solvent, it obviously is going to require some volume within the solvent, and only then it will be soluble or it will dissolve. So envision that you have, let's say, a beaker, and you have these particles of the solvent, and there are these spaces in between. So what we are saying is that these spaces are now going to be picked up, they're going to be held by the solute particles, and that is the reason that we are able to dissolve this. Now, when at a given temperature, when those spaces are filled up, then essentially you will say that we can't hold any more of the solute within this solvent. So in order to do that, you will then need to heat up the solvent. And if you warm it, of course, the liquid is going to expand. And as it expands, the distances between the two particles are going to increase. And so you can increase the space, and hence the amount that goes in will be higher at a higher temperature than what it was at a lower temperature. In other words, the amount that goes in, the amount of the solute that goes in a liquid at, let's say, 25 degrees is going to be much lesser than what goes in at maybe 80 degrees or 70 degrees, so a higher temperature. So realize that saturated solutions, they can be built at room temperature, or they could be built at a higher temperature. So the amount that goes in at the two different temperatures is going to be different. But realize that saturated solution will not be able to hold any more solid within that solution. So that's the maximum amount of solute that will dissolve in any given solvent. So in that sense, you can perhaps envision that it is solvent specific as well as temperature specific. Let's talk about unsaturated solutions. Unsaturated solutions are those solutions which contain less solute. So let's say the maximum that can be held. So for instance, for the case of sodium chloride, NaCl, it's 36.5 grams of NaCl per 100 milliliters of water. Okay, so we are saying that if you have water, 100 milliliters of it, you can actually add 36.5 grams of sodium chloride, and only then it is going to hit its saturation. And this is, of course, at room temperatures of 25 degrees Celsius. Now, any concentration less than this, that means if you just have maybe 18.5 grams, or if you have 5 grams, or if you have 25 grams, even 36 grams, because all of it will dissolve in the 100 milliliters of sodium chloride, all of those concentrations are going to be called as unsaturated. So anything less than the saturated value is going to be called as unsaturated. So what have we learned? There can be many unsaturated concentrations. There is only one saturated concentration at a given temperature for a given solvent. So what is supersaturated then? Supersaturated will be a situation where the solution reaches a metastable state and it would contain more solute than would be present in a saturated solution. And so in such a situation, you would see the solid crash out of the system. And a lot of times we would use the concept to purify a material. So this is like saying, some of you, those of you who are going to get into organic will do this live, but there's a lab based of it. But envision if you have during holiday time, you got the last bag of sugar and you spilled that sugar on the floor, and now it's like no goodies or some goodies using some scientific principle. What you could do is you could scoop out all of that sugar, you could dissolve that in minimal amount of water to create a supersaturated solution, filter it to remove the dirt from the sugar, and allow it to crystallize back, and that would be recrystallization. Make sure you boil the water.